Okay, I know the competition is great and John Romero is now giving a lecture, so thanks for staying with us. Thanks for having us. Our next speaker is a software developer with more than 10 years experience in server-side programming. He's currently working in Vivid Games and as a Java developer and a team leader. Ladies and gentlemen, Mr. Bartosz Firyn.
Hello. It's nice to be here with you. Today I would like to talk about the cloud solution we have used in the Realboxing 2 Rocky. So I will tell a few words about me, but it's probably unnecessary because Mr. Olaf already did this. So I'm working as a software developer, and I'm doing mostly server-side. So things like dynamic lighting, volumetric lighting, and things like game engines are not my case. So okay, when we started working on the first Realboxing, we had a need to implement some cloud functionalities into the games. For example, we needed leaderboards, we need profiles, etc. So this is the architecture of our system we have come with. It was much simpler on the very beginning, but now it looks mostly like this. So we are hosting everything in Amazon. It's pretty nice. There are a lot of services we are using. So let's take a short tour. Those are services available from Amazon Cloud. And with the red dots I marked those which we are using in our solution. So this is mostly CloudFormation, CloudFront, CloudTrail, CloudWatch, Device Farm, DynamoDB, Elastic EC2, Elastic Cache, Kinesis, RDS, and others. So now let's go through the flow and see where we are using those services and how we are using them. Okay, so after user open application store and install the game and launch it, the game immediately starts downloading some content. This is pretty common currently, because games in the application store tends to be smaller in size, but later those games downloads even a few gigabytes of data. So there are some progress bars displayed, some spinners, and this is mostly downloading the game content like tattoos, some bitmaps, and etc. Okay, so how we deliver this content? So we have a system. We call it CDS. It's an acronym from the Content Delivery System. It manage the files and upload these files into the S3 bucket. S3 is one of the oldest services which is available in Amazon, and this is they call it a key value store. But actually the value can be practically anything. So we are putting files there. So the file path is a key and the value is the file content. It's pretty cheap and it's a 5-star, it has a 5-star durability. So it means that there is a 99.9999% that your data will not disappear somewhere in the depths of the internet. It will be always available for so long as Amazon is available, of course. Okay, and then after the files are uploaded to S3, we have a Cdn layer. What Cdn is, I hope everyone knows what it is. It's a content delivery network. It's a farm of edge caches. Those are servers that are somewhere in the internet that are caching files, that are caching pages, images, and things like that. And when game client requests some content file, it first goes to Cdn, and then if Cdn cannot find file in the cache, it goes directly to the S3. This is, okay, here are the acronyms. CDS is a content delivery system, S3 is a simple storage service from Amazon, and CDN is a content delivery network. Which CDN? Well, anyone you want. You can use CloudFront, it's from Amazon. You can use Cloudflare, you can use MaxCDN, Bandwidth Hawk, etc. But the important thing is to note that if you want to have such solution, you have to choose CDN, which has some API which can invalidate your items in cache. Because if you update the content, you have to tell CDN that those old files that are cached are already invalid. So it will remove them and download the new ones. So what we learned from doing this is that you have to use CDN if you want to deliver content to the clients. It's very cheap. It saves a lot of costs. In our case, it is even 99% of traffic costs, and there are terabytes or even petabytes. It's good to have two CDN providers because some of them are pretty well. They do not have service level agreement, so they can just disconnect you and then you are doomed. So you have to have some backup. If you want to store files in the cache, if you want to deliver files to the game clients, you should compress them. It's an obvious choice because they are smaller and you pay less for the transfer. And the last and I think the most important point is to just do not waste your time building your own servers which will deliver content to the CDN, because it's a waste of time. You can use S3. It's much easier to handle, it's much cheaper, and it has a much higher data durability. Okay, So let's go further and talk about the other aspects. So after game is launched, you have to identify player. So we are using social network ID for this, and this network IDs comes from Google Plus, from the Game Center, from Facebook, Twitter, or anything you want. It's just a string. We have a load balancer which dispatch the request from the game client, and this element is also available in the cloud. So you can, of course, you can prepare your own load balancers, for example HR proxy, but it's much easier and cheaper to use the ones already available in the cloud. Since we are in Amazon, we are using also a load balancer from the Amazon. It's really cheap. It is much cheaper than having own servers farm which will load balance your traffic. And if you want to be ready for a traffic growth, you have to have load balancer, because otherwise your server can simply die. Okay, after the load balancer is are components from the system we have built, and under the hood of the system you can find some databases. Though we are using mostly MySQL, Redshift, and Redis, and DynamoDB, of course. Okay, so the things here on this picture, here are the acronyms. So SOC is it's a social component. It maps social network IDs from the Facebook, Twitter, and other social networks to the player ID. And GFS, it's an acronym from the Game Functions Service. It's also part of our system. Okay, those are the databases we are using in the cloud. It's Amazon RDS. RDS is it's actually not a database, but this is a service. This is a managed database server, which you just select what kind of database you have to use, and Amazon do all the rest. It starts the server, it manages it, and perform updates, secure it, etc. So you don't have to bother installing your own MySQL service. Or there is also Postgres, there is a Microsoft SQL server, and there is this new database Amazon came with lately. It is called Aurora, but I haven't played with it yet. But they claim it is 10 times faster than MySQL. Okay, the other database is Elasticache. It's simply a Redis shard, and Redis is simply a cache. And the other one is DynamoDB. DynamoDB is a scalable NoSQL database. And the last one is Redshift. Redshift it's quite interesting. It's a petabyte database. It can hold petabytes of data and perform parallel queries on this data. Okay. what we can do after the player is identified. What we are doing, we are storing some player-specific data in those databases. So we have profiles, and these are the profiles. It is actually the, well, you cannot see it, but it's just it's a compressed JSON in form of base in form of binary data. It's a binary data, compressed JSON in form of binary data, but here it is displayed as base 64. Okay. We are using several different compression algorithms, either the slow ones but good, and those are deflate and xip, or LZ4. It is pretty fast, but it creates larger data, so you have to choose what you need. Either you need speed or less data, and we are storing those profile in the DynamoDB. But probably we will be moving those profile into S3, because DynamoDB is quite expensive, and S3 is very, very cheap. Okay, so the other things we are storing per player are scores. So after these scores are stored, we have leaderboards, and those leaderboards are stored in Redis. There is a very nice data structure there. It's a sorted set. It performs very quickly, and so we have very good speed using this solution. But keeping the doing everything, there are some sophisticated algorithms implemented under the term of leaderboard, so we had to somehow script it, and we are using Lua. Redis has ability to write scripts in Lua, and it is pretty fast, much faster than performing the same operations on the server. Before we moved to Redis, we had a different solution for the leaderboards. We implemented our own, I can call it proof of concept. It was built on, it was written in Java, and those were simply tree maps and linked lists, which were stored in on-heap memory. The insert performance was much better, but the garbage collection, there was so much data on heap that garbage collector was pretty busy, and it was consuming even 25% of CPU just to garbage collect all the data. Okay, this slide I put here, it's just for reference. It's an administration GUI for our system, so you can create boards and just manage them. And here I put some image to show that how you can get these codes from Redis. It's from command line, but actually you can do the same from the code. Okay, the other cloud mechanic we are using is a push notification. And again, we are using push notifications from Amazon. Well, it works very nice, and I think it is much better than solution you can implement by your own. First, in our first approach to mobile push notification, we have implemented our own system that we're using some libraries from Google and APNS to send push notifications, but it's a endless road of many different and weird issues. So you can do it, but only if you know what it means. You will have to be ready for many bugs and many problems, and those problems are not the simplest ones. Mostly network issues and things like that. Okay, and SNS is it's a short from the simple notification service. It's also from Amazon. Okay. One of the core aspects we had to have in our game was multiplayer. So we chose a peer-to-peer model. So we had to connect two players so they can play. And this is pretty challenging. If you want to use TCP, it's okay, but you have to be ready for lags. But if you want to use UDP, then you have to be ready for some challenges. There is a protocol. It is called STUN. It's an acronym from Simple Traversal of User Datagram Protocol through Network Address Translation. It's a long name, but it simply punched the holes in the NAT layers, because, as you know, people in the network are under the NAT. NAT is an acronym from the Network Address Translation. And what is a NAT? NAT is actually a router. So you have to punch holes through the different subnetworks, those routers, or not, or you can. So you have to punch the holes so people can connect, because UDP is a connectionless protocol. There is no. It's totally different than TCP. In TCP you just connect and TCP handle everything, and in UDP you just send and forget. So you have to be ready for the packet loss and things and issues like that. But and the STUN protocol, which is used to punch the holes, is quite complicated. There are different NATs. There is a symmetric NAT, there is a restricted port NAT, a restricted cone NAT, full cone NAT, and symmetric firewall and open NAT. So there are many different types of this, and you have to handle all of them. or almost every one of them. Of course, there are people who cannot play in peer-to-peer model because they are behind restricted NAT, and depending on what analysis you are using, it is something between 8 to 30% of all the players. So if you are doing peer-to-peer, you have to be ready for the up to 30% of the players being unable to play with the others. So the solution for that is to have something called a turn. Turn is like a train station. So you can, if some player is behind a restricted NAT, he can jump to the turn server, and it acts as a proxy and send the data to the other player. Okay, so here are the acronyms again. Peer-to-peer. It's peer-to-peer model. I hope everyone knows what it is. It's when players are connected one to one. So there is no server in this solution. Well, I lied when I said there is no server in this solution. There is a server. It's a stun server. But it only works as a coordinator. It dispatches the addresses to the players, and then they can connect to each other. So it is not very. Rocky said that it's easy, but it is not easy. Okay, but after we work on it for some time, we made this peer-to-peer multiplayer connectivity much easier. But why to use peer-to-peer instead of having own game server? Because a peer-to-peer model is very cheap. If you want to have server solution, you have to be ready to have not only one but even several servers, and depending on how you monetize your game, it can be suboptimal if the server costs you more than you earn on the game. So this diagram here show how the stun is implemented in our solution. So players are in two distinct NATs, and they connect to stun. We have it implemented as MPS. It's an acronym from the multiplayer service. MPS tells them what are the addresses of player 1 and player 2, and then they can connect through the internet and punch holes. Okay. Okay, this is what we have in MPS. It's not only a stun server, but it is also a server which performs matchmaking process. It manages rooms, and it acts as a communication bridge between the game clients. It exposes WebSocket connection, so you can send, after the players are connected to MPS, there is a WebSocket connection established, so they can talk with each other through the UDP and the holes they punched in the nuts, But also, if you need some better way of sending messages and you do not want to rely on UDP, you can send those messages, some events or events to the WebSocket, and there is a guarantee that such message will be sent to the other place, because WebSocket is based on the TCP and not UDP. Okay, so but actually when I said that you have to be ready for the many servers being used, it's a scale. You have to have your system be able to scale up and down, because there are times, for example, when you have featuring on Apple, in Google, when your traffic can be 100 times greater than normally, and if you have only one server, it will easily kill it. Your server will die. But of course, you can buy bigger server with more memory, with more cores, but this will be financially suboptimal, because in normal case there will be much less players than your server is able to handle. And you will be using, for example, 1% of CPU, and that's a waste of money. So the best solution is to have many servers, many small servers, and scale up and down when you need more power. Amazon has a very nice tool for this. It is called Autoscaling Group. So it's a service. It's part of EC2 service. You can, and it is very nice. You can create load balancer, and in a load balancer configuration you can specify that it should monitor your server, for example, to check if CPU is exhausted or if memory is exhausted. And when CPU is, for example, at a level of 80%, it will automatically create new server. So there will be two servers, and then if those two servers are fully utilized, it will create the third one and fourth, and so on. And when the traffic is lower, it will just shut down one server, then another, and it will finally keep only two ones. So this is what we are doing. We also scale. We have our system built in form of cluster, where applications are installed on the server, and when new server is created in the cloud, it automatically connects to the cluster and takes some portion of the traffic that comes from the players. Doing cluster is not easy. There are many solutions, but we did some research and wanted to try. First we wanted to try J groups, but it was too complicated. Then we thought about different approaches, but finally we moved to the system, the framework. It's actually a framework and a toolkit. It's called akka. It's written in Scala, but you don't have to write your code in Scala. You can use Java, and this is what we are doing. We have code base in Java, and still we can use akka. So what we did to have our solution scalable, we divided whole system in the applications. So every application can do some dedicated things, some specific functionalities. For example, CDS, it's an application that handles content management. We have ILM, it handles leaderboard, tournaments, and score. It's an acronym from the Elastic Leaderboard Manager. We have SOC application, RCS application, DMS application, which handles messaging between the clients. So you can send messages, and those are that are pretty similar to email. And all of those applications are independent, and the things that glues them are messages. So this is a message-driven development. So we have many applications, and many applications, and they talks with each other through the messages. It's very nice. It is really better than having some RMS or something like that. The other aspect is high availability. And I don't know if you recall the outage in India. The portal called APUAP. I don't know if you know what it is. It's a government tool to store documents and something like that. And the people who implemented it, they haven't implemented the high availability into it. So there was a backup, but when server dies, the whole portal is simply dead, and you cannot do anything. So people were very angry because of that, and this would happen if your players cannot connect to the server. Your game is simply dead, and the hate is flowing on your Facebook page or anything you use to talk with the players. So if you want to have a server in the cloud, you have to think about high availability. So do not depend on one server. You have to have at least 2 of them. And this is this can be easily done with the other service in the cloud. Amazon has something like CloudWatch. So those are simply it collects many metrics, and you can implement your own metric. So you can monitor if you can start a monitor and periodically, for example, once per 10 seconds, check if your application is alive. Because the case when server dies can happen, but it is not very common. But the case when application dies is much more often can be noticed much more often. For example, you had some bug in your code and whole memory is exhausted and your application crashed. So in Amazon you can implement and configure some special you can configure this in load balancer. So whenever CloudWatch observe that your application died, it can restart the server and set up your application again, or hold the traffic to the different server. So if you have two servers and one of them dies, or your application dies, then load balancer noticed, when a load balancer notices it, it will automatically move whole traffic to the different server. And this is really nice. This is I cannot imagine how complicated that would be if you would have to do it on your own. Okay, so so the conclusion here is that the server and DB, and I haven't put it here, but also applications and DB failures are something you have to be ready. It will happen. Don't believe it will not happen. It will happen. Your server will die, your application will die, and your clients, your players will be left without the network connectivity. So you have to be ready for this problem. You have to have high availability support in your system. That is what we did. Okay. I already told about this, but the cloud solution from Amazon we are using is really nice. So after the server or application is dead, it simply shut down the server that is dead, and it starts completely new one. This server connects to the cluster, and this is happening automatically, completely magically, and we do not have to do anything. So only because of that I can sleep at night, because otherwise, well, it would be hard. Okay, that's all what I wanted to talk about. So I was asked to put some marketing mambo jumbo in the presentation, so you know, if you are interested, if you are a talented person and you are interested in programming, you can always join us, because Vivid Games is waiting for you. If you are doing your own games, we have a publishing program, so you can email us and let us know what game you are doing, and we can publish it. Tomorrow there will be a talk with Chris, and he's doing publishing. So if you are interested in this aspect, you can be there tomorrow and talk with him. There will be a panel discussion with Jarek. He's a boss. He's a technical director of Vivid Games, and also tomorrow there will be meeting with Marcin, and he will be talking about the App Store optimization. Okay, so are there any questions? Okay, don't be shy. Any question? Okay, so if there is no question, then I would like to thank you. It was very nice to meet with you. Okay, thanks.